Hello class, this is the first video for section 1.7. We're going to talk about functions. So let's take a look. I just want to get my pen ready. So it says relations and functions, and they talk about the weight of a growing child, how it would increase with time, right? So there's a function, right? As time goes by, the weight should increase. So if I were to sketch a graph, right, where T represents time and W represents weight, the more time that goes by, the greater the weight, right? So I might have a line that kind of slopes up from left to right. Or the amount of sales tax as the price of an item increases, right? So I would expect as the price goes up, the tax would go up, right? So if I were to try to sketch a graph, right, if this was price and this was tax, yeah, the greater the price, the greater the tax, right? If I was going to try to sketch a graph, okay? So it says this is some type of relationship between two quantities, right? Quantities were weight and time or tax and price. And there are going to be times where you want to inspect and examine these relationships or these relations, okay? Next, it says that a relation is a set of ordered pairs, right? And the domain is usually considered of the first value of the ordered pair, the x value, and the range would be the second point in the, or second value in each ordered pair, right? So when I'm thinking about this, what does this look like on my graph? Okay, the domain is what happens, is what happens in this direction, to the left and to the right. And range is what's happening going up and down, okay? So up and down is usually your y value or your second value on your ordered pair, right? So, you might think of this as like an x and a y, right? X and a y, right? X and a y. So the domain in this case would be all the x values, right? The 1, 2, 3, 4, 5. And the range would be the y values, right? This 10, the 8, the 6, and so on. Okay, so it's good to start to understand domain and range. They talk about the independent variable and the dependent variable. So again, thinking about our two examples where we had tax and price, right? Tax would depend on the price. The greater the price, the greater the tax, right? Or when we had the weight of a child and time, or the age of a child, right? The weight would depend on the time or the age, right? The older the kid, the heavier the kid, okay? So the independent variable would be, in this case, price, and the dependent variable would be tax. And with the first graph, the independent variable would be the time, and the weight would be the dependent variable, right? It would depend on the time. We'll take a closer look at this momentarily. Whoops. Let's keep going. So it says definition of a function. All right, so one way to think about it is it's a relation where each input has one output. Let's see what they've written here. So they mention if we're looking at an input-output table, no x values are repeated. So if you think about this, right, here's an input-output table. It's a little sloppy, right? So if this is x and y, what they're saying is 1, 2, 3, I don't know, 4, 5, 6. Right? If these were the ordered pairs, if you look on my x column, none of the x values are repeated. So this table would represent a function. If I kept going and I add the letter 4 and I add 6 again, even though the letter 6 is repeated, nothing in the x column is repeated. So we can still say that we have a function. This table represents a function. Okay, but if I made another table, and we have x and y, and I'm just going to make up a couple numbers here. So if I wrote 1, 1, 2, 3, and 2, 4, 5, 6. This would not be a function. Not a function. Right? Because the 1 was repeated. Okay? So just looking at the x column, nothing in the x column can be repeated, and that will allow us to have a function. We are allowed to repeat values in the y column and still have a function. Okay? Let's keep going. On the next page, they give us a few diagrams that show functions, relations that are and are not functions. So when I look at this first relation, it says is a function. So remember, when you hear the word input, think of what's traditionally your x value and output is your y value. Or if you're looking at a table, the input is usually what's on the first column and your output would be on the second column. So remember, we are not allowed to have duplicates of anything on that first column. So inputs, I have the letter P, I have the letter Q, the letter R, so nothing's repeated in this area. So each input maps to an output, we're okay, so this is a function. I'll give it a little check mark. Right? Next one, I got P, Q, and R. Right, so this is okay. This is also a function because nothing is repeated in the input bracket. But then when you look at the third relation, the input Q has 2 different outputs. And that's a problem, right? All of the other relations, right? Each input had 1 output, right? This input P has 1 output, the input Q has 1 output, the input R has 1 output. Doesn't matter that the output's the same. But when you look at this last table, the letter Q has 2 different outputs, right? So if I was drawing this as a table, I would write PX, QY, and QZ. And you see we're not allowed to have 2 Qs in the first column of our table, right? So that's why this is not a function. Okay. All right, let's keep moving. Let's keep working. If you look down here, they've actually written out the relations for us, right? So they took the graphical version, right? P to M, Q to N, R to N, and they put that in the table for us. So you can just quickly look at the table like we did up top. And again, you realize that this one is not a function because Q, right, it appears twice in the input column. Okay. Let's go to the next page. Okay, so on the next page, they give you a few exercises, and they ask, do we have a relation or a function? Really what they're asking is, does the sentence represent a function? Yes or no? So this says the height of a golf ball, the height is y, after x seconds after being hit is given by the equation. So I'm going to use my typewriter tool, and I'm going to say, yes, this is a function. This is a function. Or really, I should say the sentence represents a function because for each time, there is only one height. All right, oops, apparently I can't spell. All right, I cleaned it up a little bit, right? So, for, the sentence represents a function because, right, if you think about it, for each second, right, after 1 second, the height, if the height's not going to be 80 feet and 20 feet after 1 second, right? And after 2 seconds, the height's only going to have one value, right? After 2 seconds, the height might be, I don't know, 60 feet. The height won't be 60 feet and 20 feet. If I was going to graph this thing, you might have something that looks like this. Whoops. You might have something that looks like this where, right, remember, this is x, which is your time, and your y is your height. So if this is 1 second, 2 seconds, 3 seconds, 4 seconds, most likely the golf ball starts on the ground and it's going to go up and then it's going to come down. So each value for time will only have one value for height. So that means this is a function, right? The input in each student in the class, the output is the birthday. Okay, so again, if I were to make a table, I'm going to just use letters here. So remember, imagine M stands for Mike, B stands for Bob, S is Susie, J is Jen, right? So for each person, they're only going to have one birthday, right? Maybe mine's on the 1st and the 2nd and the 3rd, and maybe even Jen is also on the 3rd, and that's okay, right? So each input would only have one output, right? The input would be the person, the output would be the birthday. So that would be okay. So I'm going to stop here, and then we'll finish up with another video.